Hello guys, welcome to another video in the series of coding. Today we are going to do the problem which is called longest palindromic substring. So I are given a string S, you have to return the longest palindromic substring in S. Okay, let's try to take an example to understand. So we are given BABAD. We have to return which is the longest substring, that is a palindrome. We have to return the longest palindrome in this. Let's take an example. First of all, what is a palindrome? Palindrome means if you read from the starting or from the end, means you read either from right to left or left to right, it's going to read the same. For example, this is a palindrome because BAB, if you read this way also it's BAB, if you read in this way also it is BAB, right? So that's why this is a palindrome. Now in this string the maximum possible is of length 3 because we can see that BAB is a palindrome. There is no other substring which is of longer length that is a palindrome in this, because see, if you take BABAD, from the starting it will be BABAD, but if you take from right to left it will be DABAD, and both are not same, and so on, right? So in this you can take any of the answers. For example, BAB is answer, ABA is answer, but everything is of length 3 only maximum. Okay, let's take another example. Let's say let's take a simpler string AABAA. Now in this you can see that there are many palindromes. The character A alone is a palindrome. The characters AA is also a palindrome. You can see ABA is also a palindrome, but the longest one is of length 5 and it's going to be this AABAA. If you read from the beginning it's AABAA. If you read from this side also it's going to be AABA, and both are same, that's why it's a palindrome. Now if we think of the brute force approach to solve this problem, we are going to first of all list down all the possible substrings, and if you do that the time complexity will be O of n square, and then we will again need to check whether each substring is a palindrome or not. So we will keep 2 pointers, start and end, and one by one we'll keep comparing the characters, we'll keep moving the pointers and so on, right? So again it will be O of n cube time complexity to check whether each substring is a palindrome or not. To list the substrings it will be O of n square because there are going to be these many substrings, and then to find out whether it's a palindrome or not, the time complexity again will be multiplied by n. So then it will be O of n cube, but we don't want this, right? We want to reduce the time complexity. So the hint that they have given us, see, they have given us a very beautiful hint to solve this problem. If you see the hint, how can we reuse a previously computed palindrome to compute a larger palindrome? Okay, now it is much better, right? Let's say that I want to check whether the entire string AABAA is a palindrome or not. Okay, now if I want to check this entire string, right, what I'm going to do, I'm going to keep one pointer at the start, one pointer at the end. Now A is equal to A, so I will move my pointers. Okay, so now my pointer comes here at this position. Again A is equal to A, so I will move my pointers. Now I reach in the middle, and since this is a palindrome, because all the characters are equal from both the sides, they are going to be same. Okay, so this is where we can save some time complexity. We can just check if the last characters are equal or not, right? So I'm just going to check the last character, A is equal to A. Okay, this is correct. Now for the inner palindrome we can already store the answer and we can use this answer. Let's say I've already computed whether ABA is a palindrome. If ABA is already a palindrome and I know that, right? Let's say this is a palindrome I have already computed and I have stored it, then I can just check the first and the last characters. If they are equal and the inner string is a palindrome, let's say A is equal to A, the first character and the last character are equal, and the inner string in this case is ABA, is a palindrome which I have already computed, then I need not do O of n complexity to check whether it's a palindrome. I can just do it in O of 1 complexity. I can just take the first and last characters. So I need to already compute the inner string. So how are we going to do that? Now it's become very simple. So let's start from the very beginning. So for the inner palindromes, I will already have to compute, right? Let's say this is I, this is J, okay? So I plus 1 and J minus 1. Whether this is a palindrome or not, I should have already computed, right? So let's say I have a matrix and I am checking if I want to find out the number of characters, dp of ij is a palindrome or not. If it is a palindrome, how many characters, how much length does it have, right? To be a palindrome. So let's say my I is equal to 0 and j is equal to 4, right? So I'm checking whether dp of 0, 4 is a palindrome or not. If it is a palindrome, the length of this will be stored as the answer. So I will just give a condition check if s of I, s is the string, if s of I is equal to s of j, right, that means here I am just checking whether a is equal to a, right? So this is equal to this, so I can just store whatever value is there in my DP of I plus 1 and j minus 1, right? So inner string, the inner string will start from here and it will end from here, plus 2. Why 2? Because I am adding 2 new characters, right? I am adding the first and the last character. So DP of I plus 1 j minus 1 should already store 3. Okay, because this ABA is of length 3, right? So if this is of length 3 and I am adding 2 new characters to my palindrome, DP of 0, 4 will be equal to 5. It's a palindrome of length 5, obviously, right? The length of this string is 5. So this is a simple logic to solve this problem. Now how can we solve this problem? So let us start from the very beginning. We will have I and j values corresponding to where the string is starting. So my I will correspond to where the substring is starting and my j is corresponding to where the substring is ending. Okay, so let us build the matrix. Okay, so this is A, B, A. This is my I means where the string is starting. This is my j, where the string is ending. Okay, now let me quickly try to do one thing, draw lines here so that it is a little bit neater and we can easily fill the values. Okay, so we have to fill the values here. So let us start from the very beginning. Okay, let me also write the I and j values, 0, 1, 2, 3, 4. Okay, similarly let me write the j values here. This is 0, this is 1, this is 2, this is 3, this is 4. Okay, so let us start. So we are going to start from the very first thing. So this A is equal to, this I is equal to 0 and j is also equal to 0. That means our string is starting at A and ending at A. Let me rewrite the string here so that it's much more clearer. First we are at I equal to 0, j equal to 0, because you can see the I and j values here. That means our substring is starting at A and ending at A, right? So it is just one single character, 1. Now for all the single characters are always palindrome, right? You read from the beginning or you read from the end, it's always palindrome. So single characters are palindromes of length 1, right? So for all the single characters, I can just store 1. So 0, 0 is 1. Now let's say my I was here and j was here, right? So this I is equal to 1, j is equal to 1. This is also a single character. So here also I can fill 1. Okay, let's say I move my I to 2 and j to 2. This B is also a single character. It is also palindrome. So whenever we have single characters, they are definitely palindromes of length 1. So similarly, I can just fill 1 in all the diagonal values, because let's say starting at 2, ending at 2. The string starting at 3, ending at 3. It is just single character, right? So I can just fill 1. Okay, now let's fill the next values. Now you can note that we are filling values diagonally. Okay, so this is another beautiful problem where we fill values diagonally. Okay, let's continue. It will be much more clearer when we discuss the entire problem. Now let us try to fill this box, right? So what does this box correspond to? 0, 1. So I is at 0, j is at 1, right? That means we are starting from here and we are ending here. That means this substring we are thinking what to fill in this substring. Now for palindromes of length 2, it is very easy, right? You can just check if the first and last characters are equal, then it is a palindrome of length 2. If the first and last characters are not equal, then it is of length 0. That's it, as simple as that. Okay, so for palindromes of length 2 also it's very easy. You can just check, you can easily just check if the characters are equal or not. In this case, A is equal to A, right? So the string AA is a palindrome, so I can just fill 2. Okay, now let's go forward. Next box, I have to fill this box. A is starting at, in this box A is starting at 1, B is ending at 2. That means here I is starting at 1 and J is at 2. That means this string. Now A is not equal to B, right? That means this is not a palindrome. So here I can just fill 0. Very simple. Okay, similarly let's go here, 2, 3, right? So this is your I, this is your J. So I am just checking this string. Now B does not equal to A. That means it's not a palindrome. So the length of palindrome is 0 because it's not even a palindrome. As simple as that. So we can just fill 0 here. Similarly, let's check here. For this box, this character is A, this character is also A. So now again, this is your I, this is your J. Both are A, right? A is equal to A. That means it's a palindrome, and it's a palindrome of length 2. Okay, so we can fill 2 here and we can continue our iterations. Now let's try to fill this box. Okay, so this is starting at 0 and this is going to end at 2. So this is starting 0. So this is starting at the character A and this is ending at this character B, right? So this is your I starting at 0, this is your J ending at 2. Okay, so we are going to check whether this string is a palindrome. Now it's not a palindrome. You can just check the first and last characters. You need not do anything. Just check. First character is A, right? Here you can see it is A, and here this is B, right? A does not equal to B, A does not equal to B. So this cannot be a palindrome. So we can just fill 0 here. No need to just think anything. If characters are not matching, if the outer characters are itself not matching, how can it be a palindrome? That's it. Simply just write 0. Now we'll try to do it a bit more quickly, okay, because we want to fill lot of values and write the code also. Now let's consider this and this. You can see that here in this case I is at 1 and J is at 3. Sorry, we have to, yes, it's correct, I is at 1 and J is equal to 3, right? We are filling this box. So in this case, you are checking whether the string ABA is a palindrome or not. So you are just checking the first and last character. Just check if A is equal to A. It is equal, right? So now we will check whether the inner string is a palindrome. How can we check the inner string? We have to just check this diagonal. Why this diagonal? Because let's see. This is I, this is J. So what is the inner box? I plus 1, J minus 1, right? So you are just going to check if the string starting at I plus 1 and ending at J minus 1 is a palindrome or not. So if this is I and this is J, I plus 1 comma J minus 1 will be equal to this box, right? So you have to just check the box on the diagonal below. So if it is a palindrome, then we can just get its length, right? So this is having a length of 1. Now these two characters are matching. That means we have got two characters and the inner box is a palindrome of length 1. So we can fill 2 plus 1 equal to 3 in this box, okay? As simple as that. So we can just fill 3 here. Why are we filling 3? Because we have to check whether this is a palindrome. Now the inner string is a palindrome of length 1 and we have got 2 extra characters. So 2 plus 1 is equal to 3. So that is why it is a palindrome of length 3. Okay, now let's go to the next box. We are starting here and we are ending here. So I is starting at 2, J is ending at 4, right? So we are checking whether BA is a palindrome. Now B is not equal to A, right? B is not equal to A. So how can it be a palindrome? We can just fill 0 and move forward. Okay, that's it. Let's just fill 0 and go forward. Now we have to fill this box. So this box is starting at A equal to 0, ending at A equal to 3. So this is your I, this is your J. We are checking whether this is a palindrome or not. Okay, so first let's compare the inner characters. Now if we see the outer characters, A is equal to A, right? So obviously this is awesome for us. But when we check the inner string, right? When we check I plus 1, J minus 1, which is the inner string, when we check here, we see it is not a palindrome. So the inner string is not a palindrome. AB is not a palindrome, right? AB is not a palindrome. The inner string is not a palindrome. We can see we have already checked that it is having a value of 0. Inner string is not a palindrome. Even if outer characters are same, this cannot be a palindrome. AABA is not a palindrome, right? So in this case, the answer will still be 0, because if the inner string is not a palindrome, if the answer is 0, here it cannot be a palindrome. Okay, now let's continue to this box. So what is this box? It is starting at I1 and it is ending at J4, right? So we are checking if ABA is a palindrome. Okay, again A is equal to A, awesome, but A is equal to A, this is great. But if we check for I plus 1, J minus 1, which is equal to this box, this is also 0. So BA is not a palindrome, right? So even if the characters are equal, if inside the string is not a palindrome, that means that this has to be 0. There is no other option, but this has to be 0, right? So both of these are 0. Now let's come to the last box. It is starting at A equal to 0, ending at A equal to 4. So this is your I, this is your J. I is 0, J is equal to 4. Now A is equal to A, right? Outer strings is a palindrome. So we have to just check the inner string. So you will check I plus 1, J minus 1, this entire inner string, if it is a palindrome. It is a palindrome of length 3. So inner string is a palindrome of length 3. You have got 2 extra characters, outer characters. So 2 plus 3 is equal to 5. So this is a palindrome of length 5. That's it, simple. So we can fill 5 here and we can just write 5 here and we can continue and return 5 as our answer. So this is our entire logic. Now let's move forward to coding this. Okay, so let's start coding this. Let me just quickly make it full screen so that's a little bit better. Okay, so let's start. So we have to build this matrix that we just discussed. You can call it anything you like. I'm just calling it DP. And let me initially take the size of the string. So let's say the length of the string is equal to n. So this is a matrix that is going to be built of n cross n size. So let me just give the size in the matrix. Initially I'm going to fill all the values as 0. Okay, now let me start iterating with this matrix. We will also take this example that we just discussed, AABAA. Okay, we have this current string. So let us start iterating for int. Okay, by the way, we are going to iterate diagonally, right? So let's quickly discuss how to iterate diagonally. So first we are going to start with 0 0, then we are going to go to 1 1, then 2 2. I'm writing the coordinates over which we are iterating, right? So we have to iterate in this manner. First we have to start from the cell with coordinate 0 0 and go up to 4 4, right? In the next iteration we are iterating this side diagonally. So let me write the coordinates. So when we iterate this side diagonally, we are going to start at 0 1 and we are going to continue our iterations. From 0 1 we are going to go to 1 2, then we are going to go to 2 3, then we are going to go to 3 4, right? And then when we iterate in the third row, we are starting at 0 2 and increasing ij, so it becomes 1 3, then it becomes 2 4 and so on, right? So what are we doing? What are we doing is we are starting. Where are the starting position? First we are going to start iterating from 0 0. This is the first coordinate. After that, okay, this is our I, this is j. Okay, in the next loop when we start our iteration, we are going to start from 0 1. So then this is your I, this is your j, starting I and j. Then you are going to start from 0 2. This is your starting I, this is your starting j. Okay, this is for the outer loop. This is what we are going to start with our ij, and then each time you are just increasing I by 1 and j by 1. In the inner loop you are just increasing I by 1 and j by 1 every time, right? You are just doing, in the inner loop you are just always doing I plus 1 j plus 1. So when you are starting, the difference between I and j is equal to 0. Then you increase the difference and make the difference between I and j as 1. Then you increase the difference, make the difference between I and j as 2. So we can use this difference variable. Okay, in the outer loop, initially the difference between your I and j is equal to 0, and then the difference goes on up till difference less than n, right? So in our case, in the string, if n is equal to 5, the difference goes from 0 to 4. Okay, and then we can just increase our difference. So then we can take an inner loop. Inner loop is going to start with I equal to 0, and what will be your j? J is going to be simply I plus difference, right? So because the difference between I and j is defined as the difference between I and j is defined as difference. So because of which this is going to be your condition, right? Now we can just move forward. Till when can we go forward? When do we stop? Always we are stopping when the j value becomes equal to 4, right? So this is your stopping condition for the iteration. J value less than n is your stopping condition. Okay, now you can just increment I, increment j. That's it. This is a simple inner loop. Okay, now very simple logic. If I is equal to j, I is equal to j, that means we are iterating in the first diagonal, right? When I is equal to j, you are just iterating in the very first diagonal. So for the very first diagonal, the values are all going to be 1. It's very simple. dp of ij is just 1 because you have single character has only length 1, right? Okay, now we can go to else. Else, let's say if difference is equal to 1. In this case, you are iterating over the second. It has become very messy. Let me do one thing. Let me erase this. We have understood how to declare the variables. Okay, let me try to make it a little bit less messy. Okay, let me erase all this. Okay, so we have finished the first diagonal. We made all the values equal to 1. Okay, very simple. Now let's go to the second diagonal. Second diagonal, some values are going to be 2. Which values? If the strings, if the starting and end positions, right, if your I and j characters are equal, then it's going to be 2. Otherwise it's going to be 0. Very simple, as simple as that. So we can just check if s of I is equal to s of j. In that case, okay, so dp of ij, I can just give is equal to, if s of I is equal to s of j, then it's going to be 2. Otherwise it's going to be 0. Okay, for the second diagonal also it's very easy. Now comes from the third diagonal onwards, what do you have to do? Now also it's very simple. Let's take the next case. From the third diagonal onwards, you are going to just check. For example, let's consider this case. This is starting at a, this is ending at a here, right? Your I is equal to 1 and your j is equal to 3 in this box. So you're just checking if these characters are equal. If these characters are equal, you're getting the value of the inner string. Okay, so what we did, we saw the left diagonal. This is a palindrome of length 1. B is a palindrome of length 1. So to B, we are adding 2 characters which we just found, I and J. So 2 plus 1 is equal to 3. That's why we filled 3 in that box. So very simple again. Just check if S of I is equal to S of J, right? And the inner diagonal should also be a palindrome. So how will you check? dp of I plus 1, J minus 1 should be greater than 0, right? It should be greater than 0. If it is equal to 0, that means it's not a palindrome. So the outer character should be equal and the inner string should also be not equal to 0. Means this should also be a palindrome. Inner string is a palindrome of length greater than 0 and outer characters are also equal. If it is so, then in that case you can just make dp of ij equal to dp of I plus 1 J minus 1 plus 2. Okay, that's it. As simple as that. Otherwise dp of ij will just be 0, right? So that's it. These are the 3 conditions, very simple conditions. Now we can just check for the answer every time, right? So here, if this condition is equal to true, right? Now after this, we can give after these 3 conditions, we can just store our answer. We need to return the string that is a palindrome. In our case, we have to return this A string as our answer. So let me declare string answer. Okay, and let me also take one variable that is going to store the maximum length of the palindrome that we got till now. Initially it is 0, right? Initially it is 0. Now let me check if the palindrome that we have got right now, right? So if dp of ij, if dp of ij is not equal to 0, if it is a non-zero value, that means this is a palindrome, right? So the string starting at I and ending at j is a palindrome. Okay, so now I can check if now what is going to be the length of this string. The length of this string is equal to j minus I plus 1 because it is starting at I and ending at j. Let me take one example. Let's say you have the simple string ABA, right? Now it's a palindrome. Where is it starting at? It's starting at the index 0. It is ending at the index 2. And what is the length of this? The length of this is equal to 2 minus 0 plus 1. 2 minus 0 plus 1. So the length of this string is going to be equal to 3. How are you getting the length? J minus I plus 1, right? So that is how you are getting the length. J minus I plus 1 is going to give you the length, right? So this is going to be the length of a string. So I am going to check if the length of the string that I have got currently is greater than the max length that I already have, because I have to return the maximum length string as my answer, right? Then in that case, I can change the max length to be equal to j minus I plus 1, right? And I can also change my answer. What is going to be my answer? My answer is going to be the string that is starting at the index I and it is of this much length. So when you use the substr function, the first parameter is the index where the string is starting, which is I, and the second parameter is the length, right? It is the length. So I can also give max length here, right? It is the length of the string. That's it. And finally, after all this, you can just return answer. Okay, that's it. This is the simple code. Let me just slide it. So this is the entire code. Let's run and see if it's going to work. It is working. Let me just submit and see if it's working for all the given test cases. So it's working. It's working, and thank you for being patient and listening.